Okay, so I'm going to do a few examples here to start with of numbers and determining what set they belong to. You've already done the vocab. Hopefully you tuned in and paid attention and we're just like mindlessly staring off into space on that. So what this looks like is I give you a number. Say like the number 8. Right, like the number 8. And you determine what number set that belongs to. Well, number 8 we know is a counting number, so it's natural, which means it's a whole number. It's an integer, it's rational. Remember, if it's any of these, right, it can't be irrational. Okay? Something to remember there. Continue. I'm going to give you another example here, just a sec. I do also want to know from you with respect to a number, how do you know, right? How do you know it's a natural number? Well, think back to your definitions here, right? Natural numbers are your counting numbers. And 8 is most definitely one of those counting numbers, right? So it's, it's not 0, obviously, because there's no zeros in natural. But by definition, it's a counting number. And if it's natural, we know it has to be all the rest of these, right? So how do I know? How do I know it's not irrational? Well, it can be written as a fraction, right? I can write it as 8 over 1 or as 16 over 2. So that's how I know for sure it's rational. Now, I did warn you I'm going to try to trick you. So if I give you, let's say the following. The negative square root of 4. You have to think, okay, what's this number in its most basic terms? We learned about square roots. Square root of 4 is 2. You bring that negative down, it's the number negative 2. Well, it is definitely not natural then, right? It's not a whole number. It is an integer, and it is rational. Oh, something I forgot on the last slide here. Or should I say, almost forgot. So again, that how do you know part, right? Well, first off, I know that the simplest form of this is negative 2. And I know there are no negatives in natural, no negatives in wholes. Integers, though, right, and rationals most certainly have negatives in them. Now, I know it's not irrational because it can be written as a fraction. So I've mentioned that before, right? I could write this as negative 4 over 2 or as negative 16, there we go, over 8, right? I could certainly do that. It's not a very good negative 16 there. But there we go. So again, that's how I know it's not irrational. Let's do one more example here. Let's say I had 1.3 repeating. Okay, now, there are no decimals, right, in natural or whole or integer. So that comes down to, is this rational or irrational, right? Well, it is a decimal that repeats a pattern. Therefore, it's rational and not irrational. So can I write it as a fraction? Absolutely, right? This is 1 1/3 written as a fraction. So it gets us straight to the how do you know part, right? Well, again, as I mentioned as we went, there are no decimals in natural, whole, and integer. Rational and irrational have decimals, but this is a decimal that repeats a pattern, goes on forever, so it's definitely rational. Okay, your turn. Go ahead and pause here, and there are 6 in a row in Class Kick that I'd like you to work. And again, you get to think to yourself, what is the number in simplest form? So if I give you like, I'll give you a hint, 10 halves, right? That's the number 5. So think about it in simplest form. And I'm also asking on there, how do you know after each one? Okay, so you should have completed all 6 of those. Come back here and you're checking the answer. As I mentioned, as we kind of gave you a hint here, 10 halves is really the number 5. Well, 5 is a natural number. It's a whole number. It's an integer, and it's rational, most definitely. And then how do I know? Well, because it's a counting number. I know that. I know it's a counting number. So then it's not a decimal that goes on forever, doesn't repeat a pattern. It can be written as a fraction, as evidenced by right here. So that's how I know it's rational, and it's all of these as well. All right, so thinking back to when we learned about powers just the other day, this is really negative 2 times negative 2 times negative 2, which is actually negative 8. Okay, so I want to think about its simplest form, which, again, no negatives in natural and whole. It's definitely an integer, and it's definitely rational. It's not irrational because I can write it as a fraction, right? I could write it as negative 8 over 1 if I wanted to, or negative 16 over 2, or whatever it is that comes into mind there. And again, integers are all the natural and whole with their negatives included, and this is definitely one of those. That's how I know. Okay, negative 6.4 repeating. It is not natural. It's not whole. It is not an integer. It is a rational number. Remember, if it's rational, it cannot be irrational. This is a decimal that repeats a pattern and goes on forever. That's what makes it rational. It repeats a pattern. And it's a negative, so it can't be natural and whole, right? So again, that's how you know. You got to give me those words. Okay, here we have a decimal that goes on forever, but does not appear to repeat a pattern. That automatically, by definition, makes it irrational, so it can't be any of these. So that's how I know. It's a decimal, repeats a pattern, that goes on forever, or does not repeat a pattern, I'm sorry, does not repeat a pattern, goes on forever, and that makes it irrational by definition. Okay, here we have the square root of 8. Some of you are going to go, oh, 4. No. Square root of 8 is a non-perfect square. The square root of 9 is 3, right? So the square root of 4 is 2. This is one of those non-perfect squares, which means it is a decimal that goes on forever and does not repeat a pattern. You can put it in your calculator and find out if you don't believe me, but it's automatically. So anytime you have a square root of a non-perfect square, it's automatically irrational. Put it in your calculator, find out. It goes on forever, does not repeat a pattern. That's how I know. Alrighty, thinking about simplest form here. We all know the square root, if I could spit that out, of 64 is 8. Bring down that negative so it makes it the number -8. Now again, how do I know here what number sets it belongs to? Well, there are no negatives in natural and whole, so this thing's an integer, which makes it also rational, which means it cannot be irrational. Okay? If you have questions, please ask. A little bit of homework today. It's very similar to this. A couple sentences at the bottom of it as well.